Everyone, I'm Nikhita and I'll be presenting our work on the topic predicting trust relations among users in a social network, the role of influence, cohesion, and valence. So this was joint work conducted with my advisor, Professor Parthasarthi at The Ohio State University, and one of our collaborators at Wright State. So this is a brief outline of my talk. I'll first introduce the motivation of our work and our problem statement, followed by how we have solved this problem and some of our experiments and results. So over the past decade, there has been a tremendous growth in the number of people using social media as well as the amount of information made available to us via social media. So since people or citizens are such important sources of information, we like to be able to effectively utilize the data that they provide us. So one of the applications of this could be in emergency response. For example, if a disaster or a catastrophe strikes a particular area, then we can aid the government in providing timely help or prioritizing the rescue and relief efforts. So they can make use of the information posted on social media by the citizens in real time to do this. However, in order to be able to successfully do this, we need to identify which of this data or information is actually reliable or as close to factually correct as possible, and also who are the people who are most likely to post factually correct information. So this would lead to three questions arising in this context. The first is, which is the data that we should trust as being reliable or credible? The second is, who are the users who are likely to provide us trustworthy or factually correct data? And the third is, how much should we trust this data and those users? So the last two questions are the focus of this work. So I'd like to now define the way we formulate our problem. So we create a bipartite graph that consists of two types of nodes. The first is the users or the people who are using social media. The second is the topics or genres or themes that we extract using any topic modeling approach, such as, say, LDA or non-negative matrix factorization from the data set. And we build edges between the users and topics based on which user has commented or posted on which topic. And we'd like to predict the pairwise trust value between every pair of users and also develop an aggregated global rank ordering of the users based on their trustworthiness. So we study the following factors pertaining to trust, and they have been found to have evidence in social and psychological theories as well as from the computer science literature. So the first factor is influence, the second is user behavior based on social cohesion, and the third is similarity between users based on the content they post and the valence expressed in their content. So valence here is a term that is used to characterize emotions. It ranges from negative to positive. So by negative valence, we would mean emotions such as anger or fear, and by positive valence, we would mean emotions such as joy. So in the previous talk by Professor Tang, we heard about various aspects of influence. So over here, we use influence as a proxy to measure relationships of trust among users. So the idea behind that is, if a user A is able to influence another user B, then it's highly likely that the user B trusts the user A. So we measure influence using the influence passivity algorithm, which is an algorithm from the computer science literature. So it's a hit-style algorithm in which we first construct a graph consisting of all the users in our data set, and we build edges between them based on whether one user has reposted or, in the context of Twitter, retweeted a post or a tweet made by the second user, and the weight of the edges is defined as the number of posts made by one user reposted by the other divided by the total number of posts made by the first user. And we then alternate between estimating the influence and passivity the way it's done in a Hubs and Authority style algorithm. And here passivity is important because suppose there's a user on Twitter who is quite passive, generally not very active, However, he decides to repost a tweet or a post on a particular topic. So that reposting should be considered much more important than someone's reposting or retweeting, say, who does it quite frequently. So the next factor contributing to trust that we consider is user behavior based on social cohesion. So this finds support in the social theory of cohesiveness, which states that members of a group share emotional and behavioral characteristics. Also in computer science, a strong correlation has been established between similarity of users and trust. So if two users are similar to each other, they share the same emotional and behavioral characteristics, then they're likely to trust each other as well. In order to calculate the similarity between users, we make use of structural similarity, and we use the Jacquard similarity metric. So we compute the similarity based on their structural position in the network topology. And so with each user, we associate a vector of topics to which, on which the user posts, and we then calculate the Jacquard similarity between that pair of users. The third factor that contributes to trust is similarity between users based on the actual content they post and the valence expressed in that content. So we define the notion of a shared topic as one both with and without valence we consider. So without valence, it would purely be a topic on which two users post. However, with valence, it would be a topic on which two users not only post, but they also share the same valence or the same emotion regarding that topic, be it positive, negative, or neutral. And the way we measure valence is we aggregate all the content or all the tweets that a user has posted regarding a particular topic, and then we use an emotion or sentiment lexicon to do a text analysis, and from that we find an aggregated valence score. Is it positive, negative, or neutral? So we need to investigate more on this, so I'll talk about it as part of future work. So we'd also like to account for the relative popularity of the topics. So I'll explain the idea behind this using an example. So in the first figure, we can see that there's a pair of users who share a common topic T. However, the topic seems to be very highly popular. It has too many incoming edges to it, meaning a lot of users post on that topic. So in such a case, we cannot make a very strong statement about the similarity between this pair of users. However, if both of them share a topic and that topic is not as popular, for example, in the second figure, then they are more likely to be posting on that topic because of their interest and not because it's the current trend or something like that. So they are likely to be similar to each other and to trust each other as a consequence. And there's also one more aspect to this, that is the number of topics that each user posts on. So in the third figure, we can see that, again, the pair of users share a common topic. However, the second user posts on a very large or a very diverse number of topics. So in such a case, it's difficult for us to make a strong statement regarding the similarity between those users, even though they share a common topic. However, if both of them individually post on a relatively lesser number of topics, then we can make a much stronger statement about the similarity between those two users, and they're more likely to trust each other as well. So more details regarding the formula we developed to compute this are in the paper. We now combine these three factors together in order to get a trust equation to calculate the pairwise trust between every pair of users. And they are weighted by three parameters, alpha, beta, and gamma, that sum to 1. And we tune the values of these parameters using an exhaustive grid search. So in effect, we actually only need to tune the values of 2 of these parameters. The third one can be inferred based on the relationship between 3 of them. And once we get the pairwise trust scores for each user, then we can develop a global user-based ranking based on the trust score. So for this, we identify the top K users who trust every user, and then we sum up their trusts and just divide by the total number of users who are trusting. So in this way, we assign an aggregated trustworthiness score to each user, and then use this to develop a ranking of users based on trust. So I will now present some of the experiments we conducted and their results. We experimented on 4 data sets, 3 of them, the first 3 derived from social media, that is Twitter, and the last one from, it's a non-social media data set. So it's a film review data set. It has ground truth in the form of every pair of users provides a trust score to all other users of how much they trust that user. But from Twitter, it is difficult to extract any kind of trust information. So we, in order to get ground truth for that, we conducted a user study in which we just queried 10 individuals who were familiar with these domains and asked them to designate one of the user rankings that we obtained by weighting our values of the 3 parameters as ground truth, and we used that ground truth ranking in our subsequent experiments. So we tuned the values of the 3 parameters, alpha, beta, and gamma, using exhaustive grid search based approach. And so with every different set of values for the 3 parameters, we get a different user ranking. And we compared each of these rankings with ground truth, and we obtained the best set of parameter values, best matching with ground truth. So what we found was that the strongest factor contributing to trust is influence weighted by the parameter alpha. Its weight is nearly 0.6 to 0.7. And the next strongest factor contributing to trust is the user similarity based on content and valence. So these are some of our further results. So in order to validate our method, we compared each user ranking that we obtained with the ground truth ranking. So for this, in order to compare 2 ranking strategies, we used the standard technique of normalized discounted cumulative gain that's used in the information retrieval literature. So here in each figure, we have plotted the decision surface that we have obtained of the NDCG scores between each ranking and ground truth. So in the X and Y axes for each of the figures, we have plotted the parameters taken 2 at a time, 2 of the 3 parameters, and the Z axis represents the NDCG score. On the color bars, we show that it varies from moderately high, that's 0.5, to very high NDCG score of 1, goes from blue to red. And in the first set of figures, we do not incorporate valence while calculating our user similarity based on content, whereas in the second set of figures, we do incorporate valence. So we can see that the incorporation of valence lends a lot of robustness and stability to the method, because even though in both the cases we are able to reach, for one of the parameter values, we are able to reach a high NDCG agreement of nearly above 95%, but in the second case, there are no major fluctuations like they are in the first case in the decision surface as we vary the parameter values. So this shows that when we incorporate valence, we don't need to do a very intense or detailed parameter tuning. So that actually saves us some time. So that the previous one was the data set with ground truth, the results on that. This one is just one on the social media data set. So the trends are quite similar as the previous one. The only difference here is that the ground truth is not actual ground truth. It's the one that was designated as such by our user study. We next identify some top users who are trustworthy for each of these data sets from Twitter. So what we found was that as expected, many of these users were either famous in the areas of news media or journalism or politics. However, we were also able to identify newly emergent trustworthy users who were not very trustworthy or well-known in their domains to begin with, but as a result of their activities during a particular event, they gained more reliability and more trust. For example, in the second row, this user that's highlighted, He was not he was a normal civilian. However, during the bomb blast, he had provided voluntary services, help to people, and transport services to people who were stranded during the blast. So, as a result, for that transient period of time, his trust score had increased among the people in the social media. So this is an important contribution of our work, that we're able to identify the newly emergent trustworthy users, which can help the government in identifying and in providing emergency response. I will now describe some of the work we are doing and that we will be doing. So we are in the process of comparing how our algorithm performs as compared to the work in the existing literature. So far we have compared it with two methods that compute trust. One is the eigentrust and the second is tidal trust. So our results are pretty promising. We get a higher agreement of the user ranking based on trust with ground truth as compared to the others. We'd also like to understand the dynamics or the changes in trust relations when we add a time component to it. So right now, our trust score computation is only based on a particular time period. And we'd also like to extend or improve the way we are doing emotion analysis and valence-based analysis. So right now, we are just doing it based on the content of the text. So I'll just conclude by stating some of our main contributions. So we first conclusion was that influence followed by content and valence-based user similarity were the most important factors to contribute to trust relationships among users. Secondly, the incorporation of valence agreement among users increased the robustness of our method under various settings of parameter values. And finally, our approach was not only able to capture trustworthy users who were well known or popular in their domain to begin with, but also those users who were not as popular to start with, but emerged as trustworthy as a result of their activities during that time period. So that's all that I have. I'd like to thank the NSF for their support in pursuing this work, and also thank you all. Thank you.
Thank you for that talk. It was really interesting. This might be a little bit tangential, but I'm wondering in terms of trust relationships of users, how would you compute or think about irony or sarcasm in these messages, which might actually indicate that they're not necessarily in agreement or in trust about a certain topic? Seems like that's something that could throw the results totally opposite in terms of a trust relationship. Just wondering how you would think through that.
Okay, yeah, so I guess we'd have to change the way we do our emotion or sentiment analysis. Right now, we're just doing it purely based on the text, so we'd have to incorporate the way we compute sarcasm or irony into that, and that would probably, yeah, that's a good question. Thanks.